Good morning, dear students. So, today we shall begin with chapter number 9, Heat. So, on page 58, in the beginning of the lesson, you can see some pictures. So, observe and discuss. What are the causes of what you see happening in the pictures below, right in the boxes? So, in the first picture, you can see due to heat, the food is being cooked. Second picture, the boy has got fever, so he's got temperature. Next, the third picture, you can see ice is melting due to heat. Fourth picture, the people are sitting around the bonfire, so they're getting warmth due to heat. In the last picture, the animal is in the water, it is feeling hot, so it's gone into the water. It's having a bath. Now, try this. Rub your palms against each other and put them on your cheeks. What do you feel? So, all of you can rub your palms against each other and put them on your cheeks. And what do you feel now? Yes? Yes. So, your cheeks have become warm because your hands were rubbed against each other, and due to friction, heat is developed, isn't it? Now, we come to know some properties of heat energy from the examples in the pictures and the above activity. The sun's heat has many effects and uses. How does the solar heat reach the earth? Why does the heat in the water heated to boiling slowly decreases once it is taken off the flame? Where does this heat go? The moisture in the air cools down due to the ice cubes in the glass and collects on the outside of the glass. A thermometer is used to measure the temperature of a substance. We have already studied the changes in the state of matter caused by heat. Now, let us learn what do you mean by transfer of heat. First question in Can You Tell? Why does the halwai wrap up a cloth around the end of his slotted spoon while stirring the boiling milk in his large kadai? Now, we know that metals are good conductors of heat. So, heat is transferred from the milk to the big slotted spoon and it becomes hot. So, the halwai wraps a cloth around the spoon because cloth is a bad conductor of heat, so it does not allow the heat to reach till the hand. So have you followed it? Okay, the first answer. Second question. Why do we hold a steel glass in a handkerchief while drinking hot milk from it? Again, the same thing here. Metals are good conductors of heat, so it becomes hot, and to protect our hand from burning, we have to wrap a handkerchief while drinking hot milk from it. What are other examples of this kind? Make a note of them. So you can write more examples on your own. Now, when we take a hot object in the vicinity of the cold one, vicinity means in the area or close by to a cold one, the cold object becomes warm and the hot one becomes cooler. From this, we can infer that heat is transferred from a hot body to a cold body. Transfer of heat means the flow of heat from one place to another. Okay, so you can underline that. Transfer of heat means the flow of heat from one place to another. Now, use your brain power. Why do we wear woolen clothes in winter? So we know that air is a poor conductor of heat and woolen clothes do not allow the transfer of heat from the body. So to protect ourselves from cold, we wear woolen clothes in winter. Now let us go to the next page and study more about heat. So here now let us study the modes of heat transfer, conduction, convection and radiation. Apparatus, bars of stainless steel, aluminium and copper, a candle, a burner, pins, etc. Procedure. Now you can see in the picture here 9.2 conduction of heat. Take stainless steel or iron, copper and aluminium bars, each about 30 centimeters long and having the same shape. You can see in the picture the three bars over there. Apply wax spots with the help of candle at a distance of about 2 centimeters from each other on all the three bars. Stick a pin in each of these spots so that it is upright, that is, they are straight. Now insert the ends of all the three bars into the flame at the same time and observe for a while. So you can see in the picture the tripod stand is there, the spots of wax on the three bars and pins are there. So the metal strips are there and the burner is there. Now the burner is on and the metal bars are being heated. So what do you see? From which bar do the pins start falling first and why? So pins fall starting from the end near the burner. It means that transfer of heat takes place from the hot end of the bar to the cold end. This transfer of heat from the hot part of an object to the cold part is called as conduction of heat. So you can underline that sentence. The transfer of heat from the hot part of an object to a cold part is called conduction of heat. So conduction heat is transferred due to contact. Just remember that in conduction. Now, the pins on the copper bar start falling first. The pins on the steel bar fall comparatively late. Heat is conducted quickly through copper. Conduction of heat through a substance depends on the property of that substance. That conduction of heat takes place through a solid substance shows that a medium is required for conduction of heat. So you can just underline the last sentence that a medium is required for the conduction of heat. Now, how does transfer of heat takes place through liquid? So this is the second experiment, we will be seeing it. Now, apparatus required. A beaker, in the picture you can see a beaker. Potassium permanganate crystals, it's a chemical. It's magenta color or violet, dark violet you can say. A burner, a water, etc. Procedure. Take some water in a beaker. In the picture you can see. Heat the beaker slowly on a gas burner. Drop a few crystals of potassium permanganate into the water. Now watch the water in the beaker carefully. What do you see? You will see streams of water going upwards and coming back to the bottom. Due to the potassium permanganate, these magenta colored streams can be identified easily. In the picture you can see in the beaker, you can see those arrows here, blue and orange. So those are the streams and of potassium permanganate. Now, when heating begins, the water near the bottom becomes warm and its density decreases. As a result, it moves upwards and is replaced by cold water coming from above. In this manner, heat is transferred by means of currents called convection currents. You can underline that, convection currents. This process is called as convection of heat. Okay. This is the second method of heat transfer. So convection can occur in liquid and gaseous substances. Convection needs a medium. In the yellow box, I've read it. So remember that convection needs a medium. Let us go to the next page, page number 60. Now let's see the third experiment. Apparatus, a test tube, a piece of ice, wire gauze, a burner, a candle, etc. So in the picture you can see 9.4. What is going on over there in the experiment? Take some water in a test tube, wrap a piece of ice in a wire gauze and drop it in the test tube. It will sink to the bottom. Now use the test tube holder. Hold the test tube in a slant way as shown in the figure. Heat the upper part of the test tube. Stop heating when the water starts boiling. Observe the piece of ice at the bottom. The heat does not reach the bottom even though the upper part is heated. How does this happen? The density of water decreases due to heating. Therefore, it cannot sink and the process of convection does not occur. So here in this experiment, the water at the top of the test tube is heated. It has become lighter, so it does not move down. So convection cannot occur here. Procedure. Next experiment. Light a candle and stand it upright. Hold your hands on its two sides at the some distance from the candle. Bring them closer. What do you feel? Have you warmed yourself near a bonfire or in the morning sun in winter? The sun is millions of kilometers away from us. There is no air between the sun and the earth's atmosphere is only a thin layer of air close to the earth. Then, how does the heat of the sun reach us? This heat is transferred in the absence of medium. The transfer of heat that takes place in this way without a medium is called radiation. In the two examples above, heat reaches us mainly by radiation. So you can just mark this definition of radiation. The transfer of heat that takes place in this way without a medium is called radiation. Okay, so this is the third method of heat transfer. Now you can see the yellow box here. Cancel it. It is a deleted portion. The yellow box, full yellow box. Yes. Now, when the heat rays fall on an object, a part of the heat is absorbed by the object and a part of it is reflected. The ability of the substance to absorb heat radiation depends on its color and its intrinsic properties. Intrinsic means inner properties, inherent properties. So the last line you can just mark it. The ability of a substance to absorb heat radiation depends on its color and also its intrinsic properties. Now let's go to the next page, page number 61. Let's try this. Apparatus. 2 aluminium tins of the same size, 2 small glasses, water, thermometers, black paint, etc. Procedure. Paint the outer surface of one tin with black paint and let it dry. Then in both tins, place one glass each filled with water at the same temperature. Cover the tins with lids. Keep them in the sun for 2 hours. Now measure the temperature of the water in the glasses in the 2 tins. What is the reason for the difference in temperature? So here we will observe that the one glass which is painted black, the temperature is more, and the other glass, the temperature is less. So here we have seen that the ability of a substance to absorb heat radiation depends on its color and also its intrinsic properties. Now, let us see a video regarding conduction, convection, and radiation.
Let's talk about heat transfer. What we're really talking about here is how energy moves, specifically heat energy, and how it gets from point A to point B, whether it be here on the surface of the Earth, up in the atmosphere, or even out in space. Heat transfer occurs really in three ways, and these include conduction, convection, and radiation. Let's take a look at each of these, starting with conduction. This is heat transfer as a result of molecular contact. The best way to understand conduction is by thinking about an example. So here I have a metallic spoon, and I imagine holding a match underneath it. Now what we know is that spoon is going to heat up, and not just the part of the spoon that's over the match, but rather the spoon as a whole. And the reason this happens is because of conduction. Energy from the flame is causing the molecules within the spoon to vibrate, and that's transferring energy from one to the next, to the next, to the next, until the entire spoon has warmed up. That heat has transferred throughout the entire material. Conduction is going to happen most effectively in solid materials. But let's not forget about convection and radiation. Let's look at convection. This is heat transfer through or as a result of density differences. Again, let's grab that match and let's think about this for a minute. I think we all know it's probably not the best idea to hold your hand above an open flame like this, and that's because a lot of the heat energy generated by that flame is going to rise. That is purely because of the process of convection. You see, what's happening is the flame is causing the air to expand. And when it expands, it becomes less dense than the surrounding air and therefore floats upwards. And with it goes some of that heat energy. That's what convection is all about. And this is going to occur most effectively within liquids and gases. Finally, let's think about radiation. Radiation is heat transfer by wave motion. Let's pull that flame up one more time. I think we know that because of convection, heat is going to rise, but it's also going to travel outwards in the form of waves of energy, electromagnetic waves. And that's the third type of heat transfer. Radiation is really interesting in that it doesn't need a material for it to travel. So this can occur out in open, empty space. In fact, this is how energy travels from Earth's sun to the surface of the Earth. And so if we look back, we have our three types of heat transfer: conduction, convection, and radiation. And it's important to know the key word that goes with each one. For convection, it's going to be density differences. For conduction, it's going to be contact. And for radiation, it's going to be waves. We can sum all three types of heat transfer up in one diagram by looking at something as simple as a campfire. Imagine that you're camping and you hold a pot of water or stew above that flame. Well, right now in this one picture, we are seeing all three types of heat transfer take place. There's conduction happening as the flame is transferring energy directly to and throughout the pot as a result of molecular contact. Additionally, there's convection as heat from both the boiling pot and the flame itself is rising up as a result of density differences. And finally, there's radiation occurring all around the campfire as energy travels away from the flame in the form of electromagnetic waves. And that's a quick look at heat transfer.